Hey everybody, and welcome back to another episode in software engineering and Salesforce. My name is Brooks Johnson, and today we are going to talk about passing by value versus passing by reference, and what does that mean for the programs that we write in Apex. I think this is a really critical concept to understand, and getting it wrong, at least for me, when I was learning, is an easy place to introduce bugs into your software, and bugs that can be hard to find, hard to figure out where you went wrong. So we're gonna spend a little time. We'll compare maybe how this works to a language like C. Read through the docs, and we'll do a few examples, and we'll also compare like what does that mean, like value equality versus referential equality, shallow copy versus deep copy. Hopefully a lot of good stuff. So hit that like and subscribe and stick around to the end. I think we'll all learn something together. Okay, so the first thing we're going to do here is we're just going to take a look, just like always, right? We're going to take a look at the documents. So we are in the Apex docs, and we can see passing method arguments by value. And this is really important to understand. In Apex, all primitive data type arguments, so your strings, yours, right, etc., they are passed by value. And this means that changes exist only within the scope of that method. We'll show what that means. And when the method returns, those changes are lost. And non-primitive data type arguments, such as objects, right? And this is also, so your S objects, your lists, anything, objects is just about anything. When the method returns, the passed-in argument still references the same object as before the method call. And I think if these are newer concepts to you, this doesn't necessarily make a lot of sense. It didn't to me. So, that's the goal of this video today, right? To make some sense of this. So let's hop on over to Illuminated Cloud and IntelliJ, and we'll start writing a little bit of code. All right, and we're going to do a lot of, I'm going to minimize this now. We're going to actually, I think, do a lot of work in anonymous Apex today. And let me know in the comments. So I'd gone back and forth between, do we want to test and demo the code by writing unit tests or just by running it via anonymous Apex? Everyone knows I really like unit tests, but I also think it makes the video take twice as long. And this turned into, say, maybe a 40-minute video. For a concept I don't think necessarily needs 40 minutes. But if you disagree, you think it's better to do it on the tests, please let me know in the comments by all means. So right now we have this class, pass by. And this is where we're going to do most of our work, just a stub right now. So the first thing we're going to talk about is what happens, like in our docs, when we work with a primitive, right? So if I do... I'm going to say public static void, and I'm just going to call this times two primitive. All right, and it's going to take an integer. All right. And down here, I'm just going to go value times equals 2. My you see tab 9 is helping me out because I've worked through this and done a couple demos already. So value times equals 2, and all right, let's just deploy that up real quick. I also misspelled primitive there. I could see that green squiggly. So forgive me. We'll fix that. We'll fix it now. No, we'll wait till we recompile. Otherwise, I'll get all confused with my anonymous Apex and so on and so forth. All right. We have deployed. I'm going to go to anonymous Apex. And we're just going to start. We're going to declare a variable, all right, of named value, and it's a type a variable of type integer with the name value, and we're going to set it equal to the value of 10. And then I'm going to call my pass by times 2 primitive, and I'm going to give it value. And we'll debug our result. And you know what? I also meant to put a debug log in here. So let's do that real quick. Value in method call. Value. All right. Real quickly. Let's compile that. And I still didn't fix my spelling error, did I? I tell you, these long load times, I feel like, are the bane of the Apex YouTuber, right? As we sit here and we wait for this to load and trying to find some way to be entertaining while this exceptionally long load time happens. Come on. Salesforce, what are we doing? Okay. There we go. Anonymous Apex. So think about what happened. So we remember in our docs that our primitives are passed by value. So the question here is what's going to happen to this variable in here, value times equals 2, versus what's going to happen to our value here, outside of the method call. All right, let's get rid of that. Will value here, will this equal 20? Because we passed it in, right? We passed it into this method. Let's find out. Let's run it. Debug only. And look at that. Well, I didn't leave myself a space. So we'll fix that for the next time. So we could see, so inside the method call, and this is just what we saw in the docs, right? Because we passed in a value, the value of 10. Inside the method, that changed, but nothing got returned back out. So out here, our other variable, value that we originally assigned a value of 10, never changed. It never got updated. And this is compared to like a language like C, which at this point would allow us to actually use pointers and work directly with the value in memory. In this case, however, we don't have pointers. We are passing by value. So this method, it did what we wanted it to do. But if we were expecting our value here to be this variable to have been modified so we could use it elsewhere in our program, it never would have changed. So to fix this, right, what we actually have to do is, we'll just copy and paste this. Control C, Control V, we'll call it times 2 primitive return. All right, it's not a void anymore. It's going to return an integer. Return value times 2, and I am just going to get rid of that, and you know what, but this will work too. We'll recover from that. Return, and then we're going to say integer result equals, and we'll get the result. And see if we can get a faster compile time today on this one. Not looking like it. All right. Go back. Let's run it. And right, this should be, there we go. So now we got the value of 20, which is what we expect. So if you're working with primitives, and remember the passed by value, primitives are passed by value. If you're going to modify that value and you want to use it elsewhere in your program, and I mean, I'm assuming you do, or why would you have written the method? You have to return it out. If you just try to modify it inside the method, and if you're like me, you're probably like always getting this right. Like, I don't think I ever goofed this up because I returned something out of everything, because what I didn't really understand was pass by reference. In my mind, everything was being passed by value. So it's really, and now we're going to talk about pass by reference. This is where I think it's easier to get stuff wrong and get confused. All right, so let's delete that method. And we're going to take another one. So we're going to say public static void, and so once again we're not going to return anything, and we're going to call it times 2. And now we'll take a list of integers and we'll just call it integers. All right. And I'm going to loop over my integers. And I'm going to multiply each value by 2. So we're going to set I equals 0, I is less than integers dot size, all right, I plus plus. And then we're going to say integers I times equals 2. That should compile. Compiling slowly again today. Okay, back. Now we're going to test this in Anonymous Apex. So I'm going to get rid of this. And I'm going to make myself a list. Integers, new list, integers. All right. And we're just going to give ourselves a, whoops, quick little constructor up here. We'll make it, you know, just to make it 2, 4, 6. All right. I'm going to create a list with 3 values in it. List object, right? 2, 4, and 6. Now, we are going to pass that into our new times 2 method. So say pass by times 2 integers. And down here, let's debug the results of integers. And let's take a look at our code, right? So we said that just like before, we're not returning anything out of here. We are taking integers, we're taking this list, a list object. We are going to iterate over it, and we are going to multiply each value in this list of integers by 2. But nothing ever gets returned out. So down here in our original variable, right, integers, like what's going to happen to that? We're going to run this and find out. Everything got multiplied by 2, and I hope this is visible down here. It's actually a pretty small font. I realize that now in the Anonymous Apex. Everything got changed. 4, 6, or 4, 8, 12. So even though we never returned anything out, our original list got modified. And that's because when we passed this in, we didn't just pass in a value, right? We didn't just pass in a list with these values. We passed in a reference to its location in memory. So what happened when the times 2 method ran, it accessed that location in memory and updated all of those values. So because this value, right, so integers here, right, it's when we debug it, it's looking at that same location in memory. And that's why that value changed, even though we never returned anything out. And this can be a tricky source of bugs. Because I know when I was starting, like I returned everything. Because I didn't understand that I wasn't actually making a brand new copy of what we were doing. I was modifying the original thing. So to drive that point home, we're going to take this one. We're going to modify it. I'm going to say list integer shallow copy equals integers, right? Okay, so now we're making a new list, right? We took the value that's coming in through our method call, and we are creating a new list called shallow copy. And we'll even change this to shallow copy dot size, and here, right, shallow copy. All right, so we've copied our list, right? And now we're going to do the same thing. We're going to modify through it, and at the ith index, right, we are going to times equal to. Let's compile that. And while we're doing this, before we run it in anonymous Apex, right, ask yourself, what do you think this is going to equal? Considering that we are passing by reference, but we copied it, right? So what happens now when we run this? Nothing changed. Our integers still equals, it still got modified, right? So remember, so we created this list integers, gave it the values, 3 values, 2, 4, 6. Passed it in to times 2. Times 2 up here, right, creates a copy, works on the copy, but our original value still got modified. And the reason that is because when we create, what we did here, we did not copy the values. We copied the reference. So shallow copy and integers both refer to the exact same place on the heap. So when we create a new object, it goes on the heap in memory. So both shallow copy and integers, even though we have 2 names, right? We have 2 variables with 2 names, they reference the exact same place in memory. So when we changed shallow copy, we also changed integers because they are referentially equivalent. They are the same object. And so our final, if we want to avoid this, so is what if, so we can see either way, right? We've modified our original list, and this can cause bugs if you're not expecting it. What we really have to do, so we're going to change this. I'm going to refactor our name, Shift F6. I'm going to call it a deep copy. All right. And now integers dot clone. So, and there's also a deep clone method, and that is for S objects only. So when we call clone, what we're actually doing is we're not just copying the reference anymore. We're actually going to that location in memory. We are getting the values, and we are going to create a totally new object, deep copy, that has all of the values from clone, but it is a separate object on the heap, right? So, and we are going to return that. So instead of void, we're going to return a list of integers. Return deep copy, okay? And now let's do a list integer result pass by times 2. We're going to debug integers, and then we'll do another debug, system.debug. We'll say result equals results. All right, let's get everything. Let's compile it. still slow. I'm still feeling awkward while I wait for this. All right. Back to Anonymous Apex. I need to work on some knock-knock jokes or something I can tell while this happens. Okay. Now look at that. So our original list, integers, it stayed the same, 246. Our results came back 4, 8, 12. So in this case, right, because we made a deep copy, right, we took its location in memory and we copied those values into our new deep copy object. And then we iterated over those with the times equal to and returned that back out. Our original list stayed the same. Our return was modified. Now, I'm going to talk from a design point of view, and I want to say, like, I firmly reserve the right to just change my mind in 6 months on this and decide I am wrong. I used to return everything all the time. So even if I was essentially working on the original list, as we saw in our previous examples, I was going to have a return statement because, frankly, in my mind, I didn't really understand value versus reference, and I was going to pass that back out. Now what I tend to do is I only have a return type, right, if I'm actually going to make some sort of a deep copy of what that method got and return. I'm going to give you back a completely new object, right? If I am modifying the original object, I'm not going to return anything back out. And I use that actually to me, that's a design indicator. Hey, if there's a return statement, right, this method has a return, it is returning a new object. If there is no return, right, we are modifying the original object that got passed in, right? Assuming we are not working with primitives, which, as we saw, right, passed by value. If we want to make a change, we do have to return something out. Last couple things, if we want to just kind of drive this point home, we're going to go back to Anonymous Apex, Anonymous 1. So I'm going to, what we're going to do is list integer. We're going to show a couple things here. Integer list 1 equals new list integer 1, 2, 3. And first, I'm going to go up here. And we are going to do a system debug. Why are you not doing what I want? System.debug. Limits. Get heap size. Huh? Wrong. Anonymous Apex. Okay. Limits.get heap size. And you know what? We're going to be using that line a lot. We're just going to copy and paste it. Limits.get heap size. Okay, so what I want to make sure is we created this new list object that we've named list 1, and we can see our heap size increased. We put a new object on the heap. But if I do, what I want to say is I'm going to do list integer list 2 equals list 1. And then we are also going to do a couple more. So we're going to check our heap size again. And we're going to do a couple others. System.debug, and I'm going to say list 1 dot equals list 2. And then system.debug list 1 triple equals list 2. Now, and we don't use that triple equals very often in Apex, but what we're doing, so equals is going to check our values, and triple equals is going to check, are they the same, are the equivalent objects? Do they have the same reference in memory? So let's run it. All right, so we can see, this is, okay, so we created a new list, but what I pointed, the heap didn't grow, right? We created list 2, but our heap size remained the same because no new object got put on memory, right? No new object got created and put on the heap. So nothing changed. List 1 has the exact same values as list 2, but this is really important. List 2 is the equivalent object. Even though they have different names on the heap, they are referring to the exact same object. So now let's create one more, list 3. List integer. List 3 equals new list integer, and we are going to, so we're going to give it the exact same values, 1, 2, 3, but we have the new keyword here, and so it has the exact same values as everything else, but we're not copying another list into it. So now, if I check our heap size, we'll run it like this. This is pretty fast. We can see the heap size increased. So a new object was created and got put on the heap now. So let's compare our last two. We're going to do system.debug, and I'm going to say list 1 equals list 3. All right. And then system.debug, list 1 triple equals list 3. All right. And let's run this last one. See what we get down there. I'm expecting true and false. Yes, exactly. So our heap size increased. Remember, list 1 equals list 3 is true. They contain the exact same values, 1, 2, and 3. So in terms of their values, they are, but in terms of, are they the same object? Do they refer to the same location in memory? This is false. So that's it. That is pass by reference versus pass by value. We also talked about, right, shallow copies, deep copies, value equality versus referential equality. So I really hope this was useful. Let me know what you thought in the comments. Take a second, hit like and subscribe, and I'll see everybody in the next video. Take care.